Hi, everyone. This is Jamie Peterson of the Wolfram U team. We're back today with the latest webinar in the new and Wolfram Language 14.3 webinar series. Today, we'll be talking about tabular functionality and the latest in visualization and graphics. We have Carlo Barbieri from our Engine Connectivity Engineering Group, Sean Charon, a manager of software engineering on our image signal processing team, and Brett Champion, manager of visualization, ready to present. We also have additional Wolfram experts online and behind the scenes to assist with Q&A. Welcome to everyone. This should be a rich session, and we're glad to have you here. If you happen to miss any previous sessions in this series, remember that you can access recordings from that webinar series landing page, and you can access those anytime. Version 14.3 is a big release with many important new features and improvements to core functionality. There's a lot to read in Stephen Wolfram's release announcement, and I encourage you to check that out. I think we've shared a link with that in your emails and put a link to that in the chat as well. It's a good read. To try the examples from today's webinar, you'll want to access version 14.3, and we'll share a free trial offer so you can get started right away. I'm going to ask a poll question now to the webinar audience to ask if you've already upgraded to version 14.3. We have a YouTube live stream audience as well. And for those of you on YouTube, please feel free to type your responses, comments, and any questions in the chat. We faithfully review all comments and questions submitted on YouTube and the webinar platform. So I encourage you to type your questions as we go along. Our staff will answer what we can in typed responses to you. If you don't see a quick typed response to your question, please be patient. We will save some questions for the team to address at the end of their presentations. These live webinars are a great way to be heard by Wolfram language developers about the functionality you like or are looking for, and our staff values your input. You can have your voice heard by submitting questions during the webinar and by sticking around to answer our short survey at the end of the session. The survey is also where you can request a certificate of attendance from today's event. So thanks for answering that poll question. Let's take a look. Those results look pretty good. Most of you have already upgraded to version 14.3, and that's great. You'll be able to see all the functionality we're talking about today. Let's see, a download link for the notebooks appears in the sticky note in the webinar interface. So I want to point that out to you. And we'll continue to add notebooks each week as we wrap up next week with this series. So please plan to join us and check out those latest notebooks to get those examples for you to try yourself. So thanks for your attention. Without any further delay, I'll hand things over to Carlo to start our discussion about new tabular functionality.
Hello. Let me share my screen so we can get started. Okay. So today I'm going to be talking about things that are they're not going to look very fancy because there's not going to be any graphics in my talk. It's going to be very much a low-level overview of the things you can do whenever you have one or more tabulars. What some of the things I'm going to show are things that are new in 14.3. Others were already present in the first release with Tabular, which was 14.2. Okay, oh, what happened? I can't see my window anymore. Okay, some of you, I was looking at the list of attendees and I see a number of familiar names. So hi to all the people that I've met over the years at the conferences in person. Glad to see you come back. While I'm talking, I have a couple of polls that I've written about Tabular and your experience with other data science framework in other languages. And Robs, if you can make them live, that would be good to see what people have to say. Okay, let's get started. Okay, first of all, I'm gonna do a quick review of typical ways of getting the data in the shape you want from So it could be either from uh, actually, I'm not going to cover external sources because that's going to be that's going to be Sean's part of the discussion. But it's more of like we have data that is coming from somewhere and it's not necessarily in a tabular shape. How do we get it into the shape we want? So the first function I want to talk about is toTabular, which is kind of the workhorse uh, of getting stuff into a tabular. There are some limited things that you can do just with the head tabular, but toTabular offers a second argument, which is very useful. So in the most common case, what you do is you start from I like to start from columns because this lets me name my columns in from the start. And also, as some of the more expert users know, it's usually better to have things arranged this way because of packing. So having things coming in rows will repeat the keys a number of times, and it's going to be much more wasteful in terms of memory. But toTabular doesn't just work with simple lists and associations. It also works with more complicated more complicated kind of expression. So this is a data set, and it's a deeply nested data set. So if we look at the normal form of this data set, it's several layers of associations in. And with tabular, if you want to turn it into a tabular, what you can do is basically, by default, a data set will be turned into a tabular by flattening out the two outermost levels. And so what is here represented in a, let's say, dense hierarchical way, it's going to get represented in a flattened out tabular form. So if you're familiar with the old-time way of working with matrices in Mathematica, this is basically the same thing as going from an array to a sparse array. And these are these being the position of things, male, female, and Canada, France, etc. And here they're represented as these two gray columns. What are these? These are the key columns. So key columns are columns that are guaranteed to be unique. And they're very useful because they let you access things as if they were an association rather than list. So if you have a tabular that has key columns, you can use row key to index into the rows. And that's very useful. For those of you who have used other types of data science frameworks, this is similar to the concept of primary keys in SQL. And so they are unique keys guaranteed to uniquely identify a row. Tabular itself is also very useful because you can use it to change properties of the schema. So for example, I can create, if I create a tabular from a matrix, it's not going to have column keys. And so there are a number of operations that are more complicated to do. By just adding a list as the second argument, you can name the columns. And so then whenever you have a function for, say, in transform columns, you can use #x or #y to address them. So it's very practical, and there are actually a lot of operations that can't be done on tabulars that have anonymous columns. So we strongly encourage you to name your columns. It's also going to make your life easier to remember column population rather than column 13. Then there are other things you can put in the second argument, and they're typically arguments to tabular schema. So for example, I can set manually one of the key columns. Another thing that you typically want to do before you start the real work is to get your data in the types you want. So for example, here I am casting the column X to a quantity columns, and this now gains this little m here, which means that now X are meters. So in general, cast operations are very, very fast because either, for example, in this case, they don't really need to even touch the data because the data is stored as reals at rest, and the change of unit is just a change in metadata. So it's going to be order one operation, or they are very fast because everything in Tabular is very fast and vectorized, and if possible, happens in directly in the kernel. Another thing you can do in cast columns is called interpreter types. In this case, this is kind of a silly example because all these things are like sub-second, so they turn out to be the same date if you run interpreter Unix time. And in some interpreters are going to be faster in Tabular than they are otherwise. But and we are planning to in general improve interpreter functionality in Tabular by getting more and more things to work as fast as possible. Because we've noticed that a lot of you like to use interpreter for data cleanup because it offers a very rich language for this kind of stuff. Moving forward. So this is, I wanted to draw this picture just so that then the operations that I might use in the following slides make sense for you, and we have a common language for this stuff. Okay, so the first way to combine two tabulars is by stacking them vertically. So join, the familiar join in the Wolfram language, since tabular, the normal form of tabular is a list of rows. If you join two lists of rows, you're basically stacking the tabulars vertically. So if I have one tabular and another tabular, so each of these has 100 rows, if I stack them vertically, I get a tabular that has 200 rows. Nothing special to that. But what happens when the columns don't match? What happens is that it's basically what would happen if you were to join the normal form of the two tabulars. And so you'd get one column with all the X's, and next to it, the Y's are missing because they're not present. And then after a while, you get all the Y's. So that's obviously this is a kind of artificial example with just there's not much overlap, but you might be in some situations where there are some columns that appear for a bit and then disappear, and it's useful that no data gets thrown out. Another example of data that doesn't get thrown out is whenever you have two tabulars that have the columns that are named the same, but where the types don't match. So what happens when you try to stack them together is that typically we try to get them all in a common type that is large enough in a typed sense to hold them all. So in case of real and integers, we can pretty faithfully, not exactly faithfully, represent integers as reals. But if you were to, for example, join strings and quantities, then the type would become inert expression. So which is like kind of the fallback type that can contain anything under the sun. So it's pretty useful to keep this in mind when joining tabulars vertically. That given that storing things in inert expression is usually pretty inefficient, and you might want to do some casting before you stack them vertically, so that there's no issue there, and you get exactly what you want. Okay, so one thing to remember when joining is also that if you start with two tabulars that have key columns, maybe I should show them because they look different. So if these are tabulars where these columns are guaranteed to be unique, when you join them, this property is dropped. Why is that? Because now there's a repetition. And so we cannot, in general, guarantee that when you join two tabulars vertically, they will still have unique keys in the column X. So, and if you try to force it to do that, you'll get a failure that tells you, what went wrong. So what you can do is use delete duplicates by to actually put them in the right shape. So far, so good. These are pretty much familiar operations to people who have used the Wolfram language before. So let's get into more data science-y. It's a territory that might not be as familiar to all the Wolfram language users. And it's a function that has actually been introduced in version 10, if I recall correctly. So more than 10 years ago, it's join across. And join across has been left lingering for all these years. We haven't touched it much, but now, given the arrival of Tabular, we've decided it was time to teach it a few new tricks. So first of all, I want to explain why join across is a useful function, and why is it so central to the typical workflows you have when working with large amounts of data. The reason is that typically nobody really wants to store data at rest in a non-normalized way. What do I mean by that? Imagine we have an ERP system for a company where all the employees have like a role in a database, and all the departments are also cataloged, and the offices. It's a large corporation and has many employees, many offices all over the world. In a situation like that, you probably don't want to store the address of the office in Tokyo next to all the employees that work in Tokyo. Because what's going to happen is that if somebody moves, or if there's a change of address in the office, or for whatever reason something changes, you don't want to have to go and update it next to all the employees. What you're typically going to do is to store the employees somewhere and store the information about the offices in another place. And this is also what we do at Wolfram, because as you know, like when you look at the entities in the Wolfram language, you're going to have an entity type for cities and an entity type for countries. And you typically are not going to store the population of the whole country within the city. You can take the city, ask for what the country that city is in, and then query the properties of the country itself. So join across is like an algebraic operation that helps you take data that is stored in separate tabulars or tables and bring it together so that you can perform operations at the same time. So as an example of this, I'm going to take a table of capital cities in the world. Each of them will have like a column with the name, a column with the population, and a column with the country. And I'm going to have another table another tabular that contains the countries and the population of those countries and the area. And the question I'm trying to answer is, what are the countries where the largest fraction of the population lives in the capital? So in order to do this, to answer this question, the only way I have is to collate the information in these two tables. And so what I'm going to do is construct another table with join across that puts country compares country to name, and so country in the cities tabular and name in the country's tabular are going to be the same. When they are the same, they should be joined in a row. The problem is that if we do that just in this very simple way, we're going to lose information, because both of the tables have a population column. So and this is where what I've shown so far is something that you could do in version 10 with lists of associations or data sets, whereas this is something new in 14.3. You can, since Tabular supports this kind of special extended keys that have many levels in them, you can basically use join across to naturally add another level to the extended key, so that you basically can keep all the columns in the tabular. So now we have a tabular that contains both the city and the country population for the capitals, and we can compute using transform columns. You can compute the capital fraction by dividing. You see, this is how you access the extended key. If they're both name population, you have to actually type out extended key city population. You compute the fraction, and then you reverse sort by the fraction, and you get some interesting stuff if you do that, because well, this is a bit too big for my but it's interesting because in some cases the capital fraction is larger than 1 because of, I guess, data normalization. These are all very small places like the Vatican, but as soon as you get like there are some, like for example Beirut is 40% of Lebanon, so that's, I guess that's I mean, the first few interesting results start here with countries and cities that have over 1 million people in them. So we've answered the complex question that was not possible by working with a single tabular at the same time. It was a simple example because, well, it's not entirely true, but most countries have only one capital. And so there isn't much of an issue when trying to join in these two tabulars across, but in some situations you might run into issues. So I think a very natural example to start thinking about this stuff is by looking at time series that come from financial data. So for example, I'm taking here Microsoft, which is on the New York Stock Exchange. And so if I get a time series for year to date to now of all the close values, I'm going to get some 176 dates where the stock exchange was open and we have a close. But then if I take another stock, I'm taking ENI from the Frankfurt Stock Exchange. Of course, the Frankfurt Stock Exchange is going to have different public holidays, and in fact, it has been open 3 days more than the New York Stock Exchange. I wouldn't have thought that European Stock Exchange was going to be open for more days than hardworking Americans, but so it is. So I can join them, and here I wanted to show you this interesting way of chaining operations on Tabular. That all of the Tabular operations have like an operator form, and you can use this kind of point chaining by using / by applying it. So basically, I'm taking the joined version, and then I'm reconstructing the columns so that I'm keeping the dates for all of them, and then I'm also removing all these extra prefixes, and then I'm sorting by date. And basically, I mean, this is all CRUD to get the data in a nice shape that I'm going to reuse. But what I want to show here is that the third argument of join across is what lets you choose how to parameterize who wins between the New York Stock Exchange and the Frankfurt Stock Exchange, depending on what operation you're doing. So in this case, I've elected to keep all the dates where both are open, and so there's not going to be any missing data here. It's compact, but it has only 172 days in this data set because, of course, you take the closing days of what. And the other, I'm guessing, I don't know, in Germany, they close for, 1st of May, and in the US, they close for Labor Day, but they're not on the same date. And so that's what happens here. And then if you choose outer, on the other hand, you're choosing to keep all the dates where either one of them was open. And so in this case, you're going to have some missings. So the 9th of January, for example, but you're going to have 183 data points. So supposing you can deal with missings in some way, like interpolate or impute them in any other way, maybe using the wonderful transform missing function that we've introduced in the past version for Tabular, then maybe you should use outer. And if for whatever reason you think that the New York Stock Exchange is the one that should decide everything, you choose left. When you choose left, basically, you're going to get a number of missings coming from the days where when you choose left, you get all the dates where the New York Stock Exchange was open. And so if the Frankfurt Stock Exchange was closed on one of those days, you get a missing. Or you can choose right for the opposite, where the date column is going to be exactly the same as the date column from Frankfurt, and you're going to get some missing in the Microsoft data that comes from, as you can see here, from New York. So this was to basically introduce what the third argument does. Now, as for the fourth, sorry, that was the fourth argument, not the third argument. Let's go back to the third argument. So the third argument, this is one thing that we've introduced just in 14.3 and that we think is very useful. If you remember from version 10, join across only supported comparing one key to another or multiple keys together. But the idea was that you had, if you look at the examples before, here I've set date, which means take date from the left, date from the right. If they're the same, keep that row. And if you look at the example here, I'm choosing one key on the left and another key on the right. And it's also a list of rules is supported, so you can compare multiple keys that are different on the left and on the right. what we did in version 14.3 is that we've introduced a function syntax. So basically, all the other things can actually now be written by a series of same queue statements with tied together with AND. But sometimes you are in a situation where you need to compare things a little bit in a more fuzzy way. So for example, here is an example where you have a number of isotopes, and typically the name of an isotope is the name of the element dash a number. And so you can basically now join these two tables together. And as you can see, in this case, we're replicating uranium, the data for uranium for all the isotopes, which is something that you probably don't want to do at rest because it keeps your data much more compact. But it's important if you want to compare, say, the atomic mass of the element, which is the average atomic mass, with the atomic mass of the isotope. So in this case, what we're doing is we're we're going to have two atomic mass columns, and we can say what are the light isotopes compared to the average, and what are the more heavy isotopes, for example. Okay. I'm going to look at, before I go to my last slide, I'm going to look at questions and polls. And okay, we have one person who has comments on Tabular. And if this person would like to take the survey and tell us something about it, we'll be happy to reply. And I encourage, I hope that all the persons that are curious are gonna try it out. It's also very interesting to look at what other data science functionalities people have used. I have to say that I am very impressed that many Wolfram languages are polyglots, which is a very good thing, I think. So I hope you will find our functionality better, of course, but it's great that you've tried it out and you know other stuff, because that's what keeps also the suggestions coming. So okay, I'm gonna go back to my slides. Last thing I want to show is column-wise combine, which is basically an n-ary version of join across. So basically now you can take 3 tabulars and you can do basically pretty much all the things that join across can do, but all of them together. So in this case, I'm combining 3 tabulars and I'm matching the A and B columns, and I get this wonderful other tabular, which has lost some columns because of because there were collisions on the column names. But of course, you can do the same prefixing trick that I shown before by using alpha, like in this case, alpha, beta, and gamma as prefixes, and you can also specify separate keys for each tabular by putting another rule here. You can use a function, and there is also a syntax for specifying basically the equivalent of inner, outer, left, right. I'm not going to go too much into detail here because I think that the examples will get a bit abstract and complicated. So I think that we're fine with binary stuff for now. I'm going to see if there are any questions I can answer live. Otherwise, I'm going to go so there are questions that are answered already. I don't think there's anything new for me here to say, unless you want to get something in the 11th hour before I leave it to Sean. But I'm gonna hang around and answer some stuff on the chat as well, just not live. So okay, so our next presenter is Sean, please, Sean, you can take the stage.
Thanks, Carlo. My name is Sean Charon. I'm a manager of software engineering here at Wolfram Research. I'm going to go ahead and share my screen here. And we're going to be talking about import formats and data connections that are specifically relevant to Tabular here. So anytime that we introduce a new data model or a new big feature in Wolfram language, it has to work on data within the language, but we also have a huge emphasis on being able to bring data in from other systems so that you can work with your own data no matter where it lives. And we're constantly improving on making that process as seamless as possible every single version. This version particularly, in import-export, we have some fantastic updates in Markdown. AVIF was added. JSON lines is a new format that's really popular with Tabular to give lots of log information, and is more up and coming. We also made some updates to existing log formats so that you can bring in your Apache or other common log formats into a tabular object directly. And there's a big push for getting data connected to other systems that are not necessarily on your computer, which data connection object makes it possible to seamlessly import directly into memory data from these other systems. At 14.3, we expanded on it with OneDrive and Kaggle as file system type connections. Kaggle is pretty nice because that gives you a wide variety of sample data to bring in and play with from the wild. We also introduced relational databases, which has always been a part of the plan in terms of data connection being a more general thing that's going to grow not only the number of connections, but the number of categories of connections. So right now we have relational databases and file systems under control and growing, but you can expect to see more connections on multidimensional databases, getting data directly from APIs, and specifically in this version, we also introduced a new way to document all of this stuff so that you don't have one long page and can give specific information by connection. So let's go through some of these import formats first. Markdown is heavily anticipated, especially for all of its uses within LLMs and whatnot. In this case here, we show that there's this example data file of a Markdown with some information about geese. A group of geese is called a gaggle. There's some fun facts in here. My favorite fun fact is actually left out, which is that geese essentially have teeth. They're not quite teeth because they're not enamel, but if you look that up, it's pretty horrifying. So exporting tabular objects, we're going to, in this case, grab 3 rows from our US states.arrow dataset, and arrow is a format that we released last version that's very efficient for working with these tabular forms. And you can export that string to a tabular, or sorry, to a markdown string that's now easily communicable with an LLM. Expression formatting function is particularly important because if you have some expression, notice that these images, there's no real way to actually, you can't directly in the markdown have an image there. Of course, you could have a link or some such that would be rendered, but you might want to actually give the Wolfram expression as its input form so that it could round trip. You might want to give some sort of analysis. You might want to do like an image detect on it, and you can pass that function right here to expression formatting function and get back some analysis applied to your data as you export it to Markdown. Snippet row count is really great because you can see kind of the top, you can see the bottom. This gives you a very quick text visualization that then you could communicate as a summary. This is a way to identify if something is completely missing or wrong from your data, and again, make it communicable as purely text. Then we have export as notebooks. So we can directly export here a notebook object. Or sorry, we imported a document as a notebook object, but now we can directly take that notebook object and export that to a markdown file. So working between the notebook syntax and markdown syntax, and also taking your data from maybe a tabular or something and making that readily presentable in the markdown syntax. AVIF is a new image format. It's static and animated, and as always, we're just trying to increase the number of formats. And since this is a up and coming format that is being used more, we added support for it in 14.3. JSON lines is a really good use case for tabular because these things are entirely uniform. It's usually one, so JSON lines is a format where every single line of the file is a line of JSON itself, and they're parsed as such. And if you were to go through and actually run a JSON parser kind of a million times on the million rows that you have, it's going to be very inefficient. Luckily, we have parsers that recognize this format and very efficiently bring millions and millions of rows directly into the kernel without any issue. Both import and export are supported in version 14.3. So JSON lines, you're able to bring your data in. You're also able to export to JSON lines. And notice this is similar to kind of the image identify example that I said above in terms of an expression function, but this is expression formatting function goes to spoken string, where it tells you a spoken description. That's what the function spoken string does of all of these flags, rather than just giving you image as a string. And like I said, similar updates have been given for the log format. Apache log is the most popular one. This got some direct attention, and logs are a format where you can have any sort of arbitrary format and you can specify with these format specifiers. That's really the main point of these log files, is so that you can say, this is the information I want logged, and then I want to be able to quickly parse that information and get some sort of metrics based on it. This gives you the exact ability to do that based on how you specified your log format when you were setting up your server before you actually collected some logs. And as you see, it's a little bit slower, but this is actually going through and applying the specific templating onto your data. But we still have quite a bit of rows coming back. Common log is a new format, which has some very specific settings that are common to a lot of log formats. Chances are, if you're getting something directly from Apache, you can just use common log if you haven't actually set up any of these data formats. And then there's this other common extended log, which these are just very common headers that are always included in this extended log format. Of course, CSV and TSV are always a big topic when we're coming into the tabular domain. There's a new option to export called expression formatting function, which we've already seen a similar thing for Markdown and JSON lines and whatnot. So this is also supported in CSV. Parquet and Orc, these are very efficient tabular formats, especially compared to CSV, where CSV is a text format. Parquet is by far the most efficient file format for storing tabular data as a file on its own. Arrow is the most efficient format in terms of communicating data, but these formats, Parquet and Orc, we have now given the ability to very efficiently take rows from a subset of the data without bringing all of your data into memory. So when you're working with something extremely large, you can take a chunk of the file in practically no time. And just some bullet point updates. Some of these formats are going to receive even more attention, but for BDF and EDF, there's new import elements, tabular and time series association. We always try to make a pass and take the stuff that we already have and make sure that it's compatible with new things. So these are formats where we already had the format and we just hooked up tabular under the hood so that you could directly get your results as a tabular. MDB is a database format. Tabular and tabular association were added. DBF, NDK, TLE, MTP, if you work with these formats, you're familiar with them, and they now support tabular directly. GPX, tabular association is a new element there. For ODS, we have sheet count and summary updated. SXC has new import options, skip lines, and header lines, which are particularly relevant if you want to get the correct part of your data as the header in the tabular itself. Because remember, again, as Carlo had mentioned, you can refer to those header names in computations. DIF supports tabular objects, and MTX has a backend update, many bugs fixed, and it's up to 10 times faster. All right, to quickly go over some data connection object updates in more detail, the most exciting thing I think for this release is the layout of the documentation, which is going to make it really simple to expand on and extend this functionality in a way that's digestible by the connection type. Because within this category, some of these things are implemented under the hood in a very raw language. Some of these things are simply a service that an API that we can access. There's a number of ways that we can implement something, and in the past, sometimes that means that the way that you interact with getting your data is dependent on the type of data that you're getting. The point of data connection object is no matter what the backend is, the interface that we present to the user is completely uniform, and there's only very specific properties that will be named according to the specific connection type. So like I mentioned, we have OneDrive and Kaggle added to this version, and the relational databases that we already supported in other areas of the language are now supported directly in data connection object, so that you can just call import, give your query, and get your data and get going. And since we're focused on this tabular data model, Carla just did a great job of explaining all these different types of ways that you can combine and work with your data. Joins are particularly important if you're working with relational databases. And we made sure that Tabular is fully equipped to do all of those operations and that it's easy to access the documentation for it. So data connection object used to really go through and document everything that it had right here on the page, but then there's different information that you might have to give for something like Amazon S3. If we look at Amazon S3, this page tells you that the keys for authentication are account key ID and account secret. This is very specific to Amazon. If you're already using the Amazon ecosystem, we've named these things so that when you're looking at the Amazon documentation, all you have to do is take one of our examples, drop in your region, drop in your bucket, and you're smooth sailing in terms of accessing your data. And I don't have a way to demonstrate it right now, but this also takes care of any sort of authentication and credentials. You can pass your credentials directly as an association, but if you don't, by default, it gives you a dialog, and that dialog allows you to type in information that's specific to the type of account or the type of connection that you just tried to connect to. And that dialog lets you save your password. This handles things securely for you so that it's easy to access data from similar containers and whatnot. If you want to get that dialog back, something that's been a nuisance in the past, you can actually just specify as the right-hand side of authentication dialog, and it will prompt you again to then enter a username and password that you can save again. There's a guide page that lists all the connections that we have available currently. This is going to continue to grow, like I've mentioned. We have relational databases, and the next category that you'll see in the next version is going to be multidimensional databases, where we're working on a number of really cool features to go from not just these relational join models, but also getting analytics of data that you've already accumulated and crafted in your company for some time. So there's also some minor updates. There's internal bug fixes that are hopefully transparent to the user, just things continuing to work smoothly. Like I said, we're going to support new types of databases next release. And if there's any sort of issues with cache data or connections not working, please feel free to reach out to me directly. And I'd be happy to assist. Otherwise, you can reach out to our tech support group, which is very good, and they'll likely route you to me if it's specific to this type of thing. So data connection object examples here. Let's take a look at actually getting some data from this SQLite file. Okay, so we have a file here that, and this is the easiest way to show some examples of SQL, but location is just the query that's telling you where to get the data, and it's the result of this query, which is then cached on your machine. And now we have some employee data that we can work with. We've also got some customer data that we can work with, and we're throwing this in a little bit out of place. It's a bonus in version 14.3 that was strongly at my request. When I worked in SQL a lot, the most common join that I ran into was a left join, because very often I want to know something about every single employee, even if they don't have a corresponding matching value on the key which I'm joining on. So Left join, very commonly in SQL will have this syntax of select from this table, left join this table, left join this table, et cetera, et cetera. And this was introduced that you can write a very similar syntax using this postfix notation of you can write the left table is emp here, so you're going to get every single result from the emp table. You're going to join the cust tables, and this is going to join on employee number from the emp table to sales rep employee number from the cust table. Or if written as one line, you could do something like look at every employee, find somebody who does not have a single customer associated with them, and take a look at which employees those are. Let's see if we have any sales reps that don't have anybody that they're actually making sales to. Maybe we don't necessarily expect that the president or the VP of marketing is the one directly reaching out to these customers, but that's some direct information that you can get in one line analytics on two different pieces of data. So this is every single customer by employee. If there's no matching employee, it won't be shown, but every single employee shows up in this list. Upcoming for data connection object, I've already mentioned that we're going to have databases. We're very interested in getting Snowflake, Databricks, and Apache Pinot as soon as possible. This is definitely the intro preview to the type of stuff that we're going to be doing, and by no means an exhaustive list. I expect this list to grow dramatically. Similarly, from APIs, there's all kinds of data that you just want access to, like similar to financial data that Carlo was just showing in his examples. There might be some astronomy data or weather data that you want access to immediately. They'll behave similar to services, but have the same packaged uniform interface that data connection object presents. So that's all I've got in terms of data. We're doing our best to make sure that you have data to work with, you have your data to work with, and you can bring it into the system easily. I'm going to hand it off to Brett to discuss how you can show off that data.
Thank you. Just a second. I managed to hit the wrong icon. So let's go ahead and share my screen. And so I'm going to be talking about two slightly different topics. The first is improvements to Tabular, especially from an appearance, what it looks like point of view. And then I'm also going to be talking about some improvements to graphics and visualizations. And so the main thing with, or the first thing with Tabular is that Tabular now accepts options, which allow us to control sort of what the whole thing looks like and then what individual parts of it look like. So if I start with this data set, this tabular object, which came from resource data, I can use Tabular to then change the options on it. And so here I'm going to say tabular of that tabular object, and I'm going to say that for the appearance elements, I want the column headers, I don't want the scroll bars, and I want the image size to be full, 120. Full in this case means that it's going to be sort of the full width of the window. And 120 is going to be what the height is. And so now, give myself a little bit more room. We can see that we have the tabular view. We don't have the row numbers on the left-hand side anymore. We don't have the scroll bars, and it's only showing about 5 rows of actual data at the moment, which is going to be useful for me in showing the next set of options, which have to do with styling the content of the table of Tabular itself. And so the way that we're doing this is by using a lot of existing options: background, item style, alignment, those sorts of things, and giving them a new syntax that is starting in tabular. It'll roll out to other things in the future, which allows us to say what we want to style using keys and an association rather than nested list type structures that we've used in things like grid and data set in the past. And so the first two keys that I'm going to talk about are rows and columns, or columns and rows. And so I'm going to say, for example, my background is going to go to columns. It's going to be blue, green, and yellow. And that's the list of things that I'm giving, and that's all I'm giving. And those then apply to the first three columns. And so this is sort of a one-to-one mapping sort of thing between what the specification is and what the columns in my tabular are. I can do a similar sort of thing for rows. In this case, I'm using as well the new cyclic wrapper to say that I want to alternate back and forth or cycle through these settings. And so in this case, the background is going to alternate between cyan and just the default background color. We also have column rules and row rules, which allow us to do things that aren't necessarily a one-to-one mapping of the rows, of the specification of the rows, of the specification to the columns. This is more of a sparse type of representation. So column rules, and I can say that I want the date column to be standard purple, and then all of the dates show up in that style. Similarly, I can say that row rules, I want the third row to be red. And with these, with all of these settings, that styling information is tied to the position in the table and not to the content of the table. And so if I sort the data, then the background is still alternating. So this was one where the third row was red. That it's still the third row. Now it's Procter and Gamble. Previously, it was Valero Energy as the customer. And so these options are good for that sort of thing of, I want my tabular to have an appearance, but the details of the appearance aren't specific to the content. I have an aesthetic appearance that I want for my tabular. There are also a set of value function keys that do work on the content. And so, for example, I can have row value function, which takes a function, and I say, if the product matches gadget, then it's going to be red. Otherwise, it's not. And so all of these rows that are highlighted in red are where the product is gadget. Additionally, I can return a rule out of this function where the left-hand side is one of the column keys. And so if the product is gadget, then I want to turn the product value to red. And now all the gadgets show up just in red. I could, alternately say highlight all the things where revenue is below 10,000 or something. And in this case, because it is tied to the data, if I sort, say, this one of these tables, then you see that the styling sorts with it. And so all of my gadgets moved up to the front, up to the top, and they are red. There's also other keys to deal with more detailed things and doing specific items. And there's documentation for all of that for more detail. Tabular also now supports geoposition as a column type. So this is just a sample data set that I'm creating here, where I have 100 random geopositions in the US, and they have 100 random values. And I'm just saying that one is position and one is value. And I'm adding an option here just to not show all 100, 100 rows or even 10 rows. And if I look at the column types for this, we see that the position is sort of this complicated geoposition type specification. And related to having geo as a column type in Tabular, we've extended the geovisualization functions to be able to take tabular input similar to what we did in the previous version, where things like list plots could take a tabular and use this arrow notation to say what columns out of that you want to use in the list plot. And so I can do a geo list plot of my tabular with a geo position and say that I want the position, and it goes into the tabular, pulls out that column, and uses that as the data for my map to show where all the points are. Little bit more complicated, something like geocontour plot. I can give the position and that value, and now it draws contours using the position and the value at that position to determine where the contour line should be. And it's not the most informative map because all the data is random. But if you have non-random data, then it'll look much better. Moving on to visualization, there are sort of multiple things that we want to look at for visualization. The first is dark mode and aesthetics related changes. I suppose this first part isn't actually graphics related, it's a general system wide thing. But we added new colors, starting with the dark colors. We've always had like red, blue, green, yellow, purple, magenta, etc. And we've had light red, light blue, light magenta, light versions of all of those colors. We now have dark versions of all of those colors. And we also introduced what we're calling standard colors. And the standard colors came about as people were working on dark mode support across the system and working on especially what the docks look like in dark mode. Because what we realized is if you have the light colors, they don't really show up well in light mode. If you have, say, these now dark colors, they don't show up well in dark mode. And even some of the original colors, there's a lot of variation in how bright or how dark they are. So purple's kind of dark and shows up great in light mode. Yellow and green are really bright and don't really show up well on a white background. And so these colors are versions of all of those that have decent contrast in either mode. And so when we're writing documentation or other things where we don't know what the environment is going to be, there's safer choices for us and for you for what colors to use so that it'll show up in light mode, it'll show up in dark mode. And we'll just flip this over to dark mode, and you can see that they'll still show up really well compared to some others. So that brings us to dark mode. And in visualization, a lot of the things in switching to dark mode just worked. because we'd sort of chosen colors carefully years ago that we didn't want too light and too dark, and so if I flip this over to dark mode, really the only colors that changed here are the frame and the axes that changed from a dark gray to a light gray. And then we had to go in and we had to fix things, sort of specifically for like those call outs that come about from plot highlighting. Um, those were things where there were some colors burnt in or um, that we had to go in and say, oh, okay, this has to actually be light dark aware. We can't just say white here or black here or something. And so the other thing we did is we went in and we were making sure that as much as possible, where possible, you can use light dark switched to specify the behavior in a plot or a chart or other visualizations. And so here I have a bar chart, and each of my styles for those bars is a light dark switched color. And so we're in dark mode right now, so we get the blue, cyan, green. These are all standard blue, standard cyan, standard green. If I switch back to light mode, then we get standard red, standard orange, standard yellow. And so that is, I won't say 100% done as a project, but 98% of sort of having visualization functions that appropriately switch things back and forth for light mode and dark mode, and that allow you to specify things specifically to how you want them to behave in dark mode. Related to sort of some of the aesthetics improvements to graphics, specifically geographics, we now have vector maps as default rather than having raster bitmaps as the background images for the maps. And so, and in addition to making the transition from bitmap to vector graphics, the styles have been updated. We were able to get sort of this terrain information that we're for land that we're able to use sort of when you're looking at large areas sort of zoomed out. As you zoom in, the terrain goes away and you get the more typical roads and parks, and that's lines and polygon types of information, types of appearance for geographics. One of the big features for visualization in 14.3 is having support for fitting directly in visualization functions. And so we added two new functions, list fit plot and list fit plot 3D, that take the data in and do a fit and show that in conjunction with the data, with the original data. And so that saves you the effort of having to do show of a list plot and a plot of whatever, result of whatever flavor of model fitting you want to do. And so here I have a time series of temperature data for Champagne from, all of last year. And I put that in list fit plot, and it shows me what all of the individual data points are, and it shows me a fit through that. The particular fit that's being used here is coming from local model fit. That's the default for list fit plot. You can choose other types of fits if you like. So I can do a linear fit. It doesn't really fit the data particularly well. I could do a quadratic fit, and it fits much better. And there's I don't know, 6 or 7, named string versions of what the fit function should be, exponential, that sort of thing. I don't have an example here, but you can also, still do a fit on the outside using local model fit or linear model fit or um, whatever, and pass that fitted object into fit plot and have that used as the fit. There's also an option called plot fit elements, which controls what elements get included relative to the fit. And so list fit plot, and I say plot fit elements goes to band curves, and I just get sort of my fit and a 95% confidence interval um, around that fit. I can include the original data points by saying I want the data points. And so now we see that, in fact, most of those points do fit inside the confidence envelope, with a few that end up outside. I can say that I want the points and the residuals, so we draw all the points, drop residual lines down to the fitted curve. And as I mentioned, we also have list fit plot 3D. Same idea, same concept as list fit plot. I've put data in this case, I'm pulling it out of a tabular object and saying I want the values from the displacement, horsepower, and miles per gallon, fuel efficiency columns. And so it went off and it did a local model fit of all of those values. And I'm showing the points, and I'm using a more verbose syntax that allows me to say, for example, how I want the points to be styled. And so we can do that, look at it from different angles. It's a very correlated data set between displacement and horsepower. So I'm not sure that I would necessarily put much stock in the result of the fit away from that diagonal, but along it, it's not too bad. And the final topic I want to talk about is some improvements we made to labeling, in particular the point labeling used by things like list plot. And we've had this functionality for, well, I don't even know how long, a long time, of being able to use labels and callouts on points, and there's a whole algorithm inside that sort of figures out where to put the labels so that, and what labels to place so that the labels aren't colliding with each other, they aren't colliding with the points, that sort of thing, that it's sort of a nice looking layout. But sometimes you want a little bit more say, or you are willing to give up a little bit more in one way or the other. And so we've added a new option called labeling target, um, which allows you to say things like, I want to see all the labels. I don't care if they collide with things, whether it's other points or other labels, just drop them all in there. And maybe this is useful in your case. But maybe that's a little bit too extreme. You didn't want that much to be done. And so we can say, for example, I want labeling target to be 0.25. I want a quarter of the points to be labeled. I want the best quarter of label positions to get their labels. And so as a result, we get a little bit of label collision here, right here, that we didn't have before. This point is getting obscured a little bit by the scrims on nearby labels. And so it's a little bit more lax in what it allows, but it's still not everything completely overlapping. And this also allows us to control various parameters that go into the label positioning. And so, for example, by default in listplot, there are 8 positions that the labels can go. So it can go to the left, it can go to the right, it can go above, below, or it can go sort of diagonal in any of the 4 corners. And the labeling target using an association syntax and I'll show a few of these keys, but not all of them, allows us to say things like, I only want the labels to be able to point, on the sides. And so then it lays it out, and you'll see that all of these leader lines on the callouts are either sort of straight horizontal or straight vertical. And it's not just that it, say, took this and threw away all the labels that were using diagonal callouts, because, for example, here we have gravel, which is using a diagonal callout by default. But when we say we only want the sides, it's still able to figure out where to place gravel. It's just able to do it using a horizontal call out in this case. One of the other things that affects the positions of labels, and so we mentioned that we try to avoid labels colliding with each other and colliding with the points. The other thing that will cause a label to get cut out, which sometimes is worth relaxing as a requirement, is whether the label is going to get clipped by the edge of the graphic. And to an I mean, the graphic does get extended a little bit to allow for label placement. So our data is between 0 and 1, and you see that 1 is right here. And we're going probably about 10% beyond that to allow places for labels. I mean, you can see it. Let's look at it up here, actually. And so you see that we go beyond 1, and then this version of plural, which I have never seen before, or at least never noticed before as a word, goes into that space. So we add a little bit of space so that things have some room. Also in the vertical direction, so musicology and arable are getting into some sort of buffer space around the outside there. But this setting in the association allows us to say, it's okay if a label gets cut off going off to the side or off to the top. Interestingly, none of them are going off on the top, but we can see that, so for example, this point, the label's getting cut off, but we can still tell what it is. It was emigrant. This is barnacle, torsion. If I knew the data, I could maybe guess that this was ceramic. And so even though it's getting cut off, it still conveys perhaps enough information for me to make use of it. And so I think that covers everything I wanted to talk about today. I'm going to take a glance at the questions and see. Let's see. Let's see. So there's a tabular question. If one specifies color rules for the background and then takes only some rows, the rules are applied again to the new subtabular, so the colors can change. And so that is. Let's go back to content styling. And so, I mean, as you say, if you take use part or something to select part of a tabular, then the options generally are carried with it. So if I were to use part to take sort of product to the right of this tabular, then product would become blue, um, region would become green, customer would become yellow. Sorry, product would be blue, date would be green, customer would be yellow. And if you're using columns and rows and column rules and row rules, that will be the case. If you use things like the function versions, then you can have it so that the styling stays with the table even when you transform it. That said, there are some operations where it's sort of destructive enough that the options aren't even necessarily carried along, especially the content ones. So things, when you start getting into pivot table and aggregate rows and things where potentially you're changing where you're adding entirely new columns, for example, that may cause it to say, I'm not sure what to do anymore, and not have sort of any of the styling carry along with it. Let's see. Is there anything new in arbitrary leader line style specifications, particularly in regard to international standards? I'm not sure exactly what that question is getting into. I think that seems like something to perhaps send to tech support, or send to us, via email, and we can have a bit more detail and look into it. Okay, sorry, my headset turned off. Will labeling target be added to GraphPlot eventually? I think it should be. And I think that would sort of happen in conjunction with other improvements and expansions of labeling in Graph. Let's see. And let's see. Question about list stream surface plot 3D. It's an interesting idea. I don't think it doesn't exist in the system right now. You aren't missing it. And I don't know if it's one that we've necessarily thought of a lot as something that would be interesting to people. And so, but thanks for the comment. Does labeling target override or cooperate with label visibility? And label visibility cooperates with labeling target. Labeling visibility is another control into that automatic layout algorithm. And so, within everything that labeling target is controlling, label visibility is used to sort of determine, do I want to... So labeling visibility is used in the sense that I have two labels, 2 points that I want to put a label on, and I don't think I can do both of them within this, within the scope of whatever setting you're using for labeling target. When you have, I could label cat or I could label dog, but not both. Which one do I use? That's where labeling target comes, label visibility comes in. Of being able to say, I prefer cats to dogs, or I always want to see the label for dog. So thank you. I think that covers most of the questions, and I will stop sharing.
Thanks, Brett. Thanks also to Sean Charon and Carlo Barbieri and everyone helping us with the questions. If there are any questions that you're continuing to type in that interface, we will review everything that's in there as we, after we close today and follow up with anyone if requested. And then, of course, the survey is your other opportunity to share some feedback with us. So thanks very much for your attention. Yep, we've got a link to that survey right there on the screen. Thank you, Robs. And we appreciate your feedback again. And just as a reminder, you can request a certificate of attendance for this event by answering that question on the survey. Next Wednesday, we'll be covering the latest advancements in geometric modeling and new features in the Wolfram compiler. So we look forward to that. We've got a QR code on the screen, which takes you to Wolfram U and other interesting events and resources for you to find there. I'll also mention that our notebook link in the handout highlighted sticky note there in your webinar interface has been updated while we were talking today. So if you haven't grabbed the notebooks in the last 30 minutes or so, you might want to take a look and make sure you have the latest. So thanks very much for your attention, everyone. We look forward to seeing you next week. Bye for now.